In this topic, we'll follow a certificate's journey from start to finish, how it's requested, issued, renewed, and eventually expires or gets revoked. We'll also see how clients verify trust in real time using certificate revocation lists and OCSP to check whether a certificate is still valid. You now have the core building blocks: why PKI exists, how cryptography works, and how certificates prove trust. Now we're shifting from theory into day-to-day operations. This topic focuses on what happens after a certificate is issued. We'll cover how and why certificates get revoked, how CRLs and OCSP provide live status checking, and how expiration and renewal are managed so trust is maintained continuously, not just at enrollment. Treat a certificate as a living security asset, not a static file. It begins with a request, is evaluated and issued by a certification authority, then gets deployed to a system or user and actively used for secure authentication or encryption. Over time, it must be monitored, renewed before it expires, or revoked when it's no longer trusted. Managing each stage well prevents outages and keeps your ADCS environment reliable and secure. Every certificate starts with a request from a user, device, service, or admin. That request includes identity details and a public key, while the matching private key stays safely with the requester. Active Directory Certificate Services receives the request, checks it against the appropriate certificate template, and determines whether it's allowed. Requests can be submitted manually through auto-enrollment or using tools like Certrec and PowerShell. If policy is satisfied, the CA issues the certificate back to the requester. Before issuing, the CA is really answering one question: should this identity be trusted for this purpose? It checks who the requester is, which account they're using, and whether policy allows them to enroll for that certificate type. Templates enforce details like subject naming, key usage, and which groups may enroll. For higher-risk certificates, an admin may need to approve the request manually. Those strong approval gates prevent attackers from minting unauthorized certificates. Once the CA approves a request, it signs the certificate with its private key. That signature is what makes the certificate part of a trusted chain. The issued certificate now includes the subject identity, its public key, validity dates, and the permitted key usages. Next, it must be imported into the correct certificate store: user, computer, or service. Finally, specific applications like IIS, RDP, VPN, or Wi-Fi are configured to actually use that certificate. After deployment, certificates become part of everyday operations. They secure TLS sessions, authenticate users and machines, sign data, and protect confidentiality. The catch is that certificates often fail quietly. They simply expire, and suddenly a website, VPN, or domain service stops working. Operational teams need a live inventory, clear ownership, and automated alerts for upcoming expirations, especially on business-critical systems. Think of it as uptime monitoring focused entirely on certificate health. You can also think of certificates as perishable items with an exact use-by date. Renewal means issuing a fresh certificate and swapping it in before that date arrives. With auto-enrollment, much of this can happen automatically for users and machines. When renewals are missed, things break. TLS fails, logons stop, integrations go down. To avoid that, you plan renewals, test them early, schedule outages where needed, and know how to roll back safely if something goes wrong. Consider a company laptop with a machine certificate that gets stolen. The attacker now holds the device and potentially the private key, while the certificate still appears valid. Revocation lets the organization cut trust immediately. The incident is reported, the CA revokes that certificate and publishes its updated status. Any client that checks revocation will now refuse connections using it, so systems stay protected even though the original expiration date hasn't passed. Think of revocation as a controlled kill switch for certificates. First, you identify the exact certificate and confirm why it must be revoked. Common reasons include key compromise, CA compromise, an affiliation or ownership change, a superseding certificate, or complete shutdown of the service. Then you revoke it on the CA, publish updated CRLs or OCSP status, and finally confirm that clients actually detect and block that certificate. Archiving private keys is mainly about encrypted data, not signatures. Here's the idea. When a user gets an encryption certificate, the system can securely store a copy of that private key. If the user loses access, a designated key recovery agent under strict authorization can retrieve it, so business data isn't lost. The trade-off is clear. You gain strong continuity benefits, but you also introduce serious risk if those archived keys aren't tightly protected and audited. A certificate revocation list is essentially the CA's do not trust list. The base CRL is a complete snapshot of every certificate the CA has revoked up to that point. Delta CRLs act like incremental updates, listing only what changed since the last base CRL. Clients combine a recent base CRL with any newer Delta to get the full picture. This keeps revocation information fresher while avoiding large downloads every time. Every certificate carries pointers that tell clients where to fetch revocation data. These CRL distribution points can be HTTP URLs, LDAP paths, or even file shares. When a client validates a certificate, it follows those locations, downloads the CRL, and checks whether the certificate's serial number appears. Publishing intervals determine how fresh that list is. If CRLs aren't published often enough, or the CDP locations are unreachable, you'll run into certificate validation failures. When a client evaluates a certificate, it doesn't stop at the trust chain and validity dates. It also needs to know whether that certificate has been revoked. With CRLs, the client periodically downloads a list of revoked certificates and searches it locally. OCSP flips this around. The client asks an OCSP responder about one specific certificate and gets back a status of good, revoked, or unknown. In Microsoft environments, that responder is typically the online responder role. You've now seen that certificates aren't fire and forget. They move through a full life cycle, and you must manage renewal, expiration, and especially revocation. Clients rely on CRLs and OCSP to verify trust in real time. Next, we'll put this into practice by building an enterprise PKI in an Azure-based lab.